Hey guys, today I'm going to be showing my capstone project. It's Pac-Man. I'm pretty sure most of you guys have heard of it or played it at least once. I am using the same screen Cast-O-Matic, so I only have 15 minutes maximum. So I'll try to be quick and concise about my demonstrations. So beginning here, we have PHP code. You do need a server to run this, otherwise your content's not going to show. And I have 31 rows and 28 columns. And this two-dimensional array right over here is going to be with values of all 0. 0 meaning that the ghost and the Pac-Man player will be able to traverse. All these for loops right down here are going to be making those zeros into ones, certain tiles from 0 to 1. We keep on going down. We'll find this piece of code right here, which is going to be a JSON message to send that two-dimensional array in a JSON message to the JavaScript, which we'll go into in a little bit. Here's my style. I didn't use CSS because there was only, several of them, few of them, not that much. So SVG gonna give the properties to my scalable vector graphics. I'm not using Canvas or anything. Scalable vector graphics. Game result, that's basically a text. So this is basically just to give graphical properties to the values of my game. So right down here, here's my variable instantiation. So edible equals false is kind of vague, but that basically means whether the ghosts are edible or not, and it's false because the start of the game, the ghost should not be edible, and ghost speed is 30 by tiles are going to be 30 by 30 pixels. So that means ghost speed is going to be 2 pixels. If the ghost is going left, then it's going to subtract 2 pixels from 30 is going to make it 28, so it might be 28 by 30. If you keep on going down, here's my ghost algorithm. We'll get back to it in a little bit. I'm just going to show you the graphical demonstrations for it, rather than walking you through the entire code, as it is confusing and long. But here are basically my functions to make my game work. Moving, turning, moving Pac-Man, those are all going to be, and equals, that's all going to be properties of Pac-Man. And player movements. And here's the main function called game. So here's most of these methods, because some of them are going to be sub methods inside of a method that's inside of this main method. And here is my loop request animation frame. It's different from a time loop. They basically request for the animation frames available on your monitor or your computer. And if it's 60, then it's going to divide that by 1000 intervals, and I'll give you 13 milliseconds to complete this entire method. Here's my key codes. So W is going to be key code of 87, S down is going to be 83, so forth. And basically tells the program to loop through the game now. So we're going to go back to the algorithm now. Like I said, I'm not going to walk you through it. It is kind of long and confusing. But here is my graphical interface for it. Right over here. So the green is going to be the starting, and the red is going to be the end. And the yellow path is the preferred paths. Gray tiles are going to be the checked tiles. And the black tiles are the tiles that's not checked and is ready to be checked. What this does, well, the algorithm that I'm using is a breadth first search algorithm, and it's mainly used for graphs. As you can see, this is basically a graph. Value of 0, 0, right is going to be 1, 0, down is going to be 0, 1. Reaches all the way to the end, 27, 30. So currently the starting value is going to be 9, 8 with the starting value of 0. And what the program does, the algorithm does, is that it's going to look at the neighboring nodes, and if it's not checked, and if it's not a 1, then give that node a checked value of 1. And then from that node, these two nodes over here, then it's going to continue checking up, left, right, and down. So if the next node is not a checked node, which is what these are, doesn't have a turn value assigned to it, and is not a 1, and is ready to be checked, then assign a new turn value to it, increments by 1. So right over here, you can see 1, 2, 3, 1, 2, 3, and once it reaches an intersection, it's going to check both sides. Well, it's going to check all the tiles around it, and if it meets the conditions, and assign a turn value to it. So, and we could change up the numbers as well. Let's do that really quick. And like I said, it's mainly used for testing purposes. So start backs is 9, 8. That's where we are. Let's change it to 14, 11. Save it. As you can see, it shrunk a little. That's because it doesn't require that much time to. That's because it doesn't require that much turns to find it. So it's going to require 21 turns to find the end value, and what the end value is going to do is going to backtrack the turn values to find the starting point. So there are other ways for it to find. So for example, 21, 20, 19, it's not going to go up to 20 because that wouldn't make sense. 16, there's two 15s over here. It could have taken this path as well, but it decided to take this path as it is the same value, same distance. I mean, so let me show you guys the game now. Well, actually, first of all, these are all going to be the check coordinates, the gray tiles, with the turn values. There should only be one turn value of 0, and 14, 11, that's right over here. And it checks 217 coordinates. So there's 217 checked gray tiles in this grid. And right down here, this is basically the preferred path, the coordinates as well as the turn value going down, decrementing. So let me show you guys the game now. So this is how it looks like once you reach the page. Here's your keys right over here. So W up, A left, S down, D is right, space bar is going to be pause and play, shift is going to be restarting. If you eat the big balls right over here, and the ghost is going to turn blue and worth 50 points. Otherwise, if you eat the balls, either big or small, it's going to be worth 10 points. Here's your score. Keep track of your score as you play, and the balls on your grid is going to go down as you continue to eat them. So you press enter. It's going to count down from 3 to 1. There are still some bugs with it. So as you can see right over here, so it gets stuck. So once you hit the blue ball, it's not going to chase you anymore. In fact, it's actually going to go back into the pen after you eat it. And it does slow down. So it slows down from 2 pixels to 1 pixel. It's not like the original game. I'm missing a lot of content from the original game, but yeah, if possible, I'll try to implement the most in the future, but I am not going to distribute the game. So once the ghost gets you, you basically lost the game. But if you do eat all of the balls on the grid, you basically won the game. And as you can see here, balls left on the grid, you have 215. Your score is currently 890. So that's pretty much all of them for now. Thank you guys for watching. Have a good day.